everyone. Today I am going to explain about serial in and serial out shift register. First we want to know about what is shift register. A shift register is a type of sequential logic circuit built using flip-flops. It is used to store and transfer data, shifting it either left or right when a clock pulse is applied. Here are the types of shift register: serial in, serial out, serial in, parallel in, serial out, parallel out, bidirectional shift register, and last universal shift register. Here I am going to explain about the first type, serial in and serial out shift register. It is a type of shift register where data is entered one bit at a time and is also taken out one bit at a time with each clock pulse. It is mainly used for temporary data storage and time delay operations. Here is the circuit diagram for the serial in and serial out shift register. I am using D flip-flops and I am taken as 4-bit registers. Here I am using right shift, so the data is stored or transferred on the right side. The serial data input is given into the first flip-flop and the output will be Q0. The second flip-flop's input will be the first flip-flop output Q0. The third flip-flop's input will be the second flip-flop's output Q1, and the last flip-flop's output input will be the third flip-flop's output Q2. The fourth flip-flop's output will be Q3, that is taken as the serial data output. Here I am giving clock pulse for each and every flip-flops. Now I am going to show about how the bits are entered into the shift register. The table 1 shows the entry of the all 4 bits of 1010 into the register. Initial state will be always 0. Here I am taken the least significant bit. In 1010 the least significant bit is 0. So the 0 is taken as the first input of the first flip-flop. I am giving first clock pulse. The 0 is entered into the first flip-flop and the others flip-flop will be remains 0. The second least significant bit 1 is taken as the first flip-flop's input and the 0 will be shifted into the second flip-flop. Next the 0 is taken into the third. The 0 is taken as the third input of the first flip-flop. The giving third clock pulse, the 10 will be shifted into the next flip-flops. And finally the 1 is taken as the input for the first flip-flop. By giving fourth clock pulse, the remaining 010 will be shifted onto the next flip-flops. If you want to get the data out of the register, the bits must be shifted out serially to the Q3 output. And the table 2 shows the how the output will be taken out. The initial state will be the fourth clock pulse value 1010. For here I am giving fifth clock pulse, means the Q3's output 0 will be taken as output and the remaining 101 will be shifted onto the FF1, FF2 and FF3. Next the 1 will be next I am giving sixth clock pulse, means the 1 will be taken as output and the remaining 10 will be shifted on to FF2 and FF3. I am giving 7th clock pulse. The 0 will be taken as output and the 1 will be shifted on to the FF3. And last I am giving 8th clock pulse, means the 1 will be taken as output and the remaining states will be 0. The application of SI/S4 register are serial data transfer, temporary data storage, time delay element. Thank you.